넘어가도록 하겠습니다. 다음은 그라피소프트 아코시 페메터르 부사장님께서 언제 AI가 건축물을 디자인할 수 있을 것인가 라는 주제로 기조 강연을 해주시겠습니다. 발표는 영상으로 진행하겠습니다.
Hello everyone, my name is Ákos Femeter and I am working for Graphisoft as VP Technological Partnerships. In this capacity, I am dealing with large AI providers such as NVIDIA, Microsoft, Google and others. Today, I would like to talk to you about how AI will disrupt the construction industry. Let's start with a question. When do you think AI will design our buildings? Great question, because when it will, the construction industry will be much different than today. On the one hand, buildings will be more algorithmic, more optimized, more efficient. But our jobs will be different too. We will design and deliver buildings differently, hopefully with much less manual work. But we may even end up not having a job as a designer at all. So we better pay attention to what is happening around AI. We cannot afford that this technology revolution just happens to us. We have to take an active role in it, and the first step in that is understanding. If we want to understand AI, we can start by looking at various AI examples out there. AI apparently is disrupting many areas of our lives already. Banking, medicine, transportation, gaming, and most recently, creative fields such as content creation with generative AI models such as ChatGPT and Midjourney. These examples can help us see what AI is capable of, but won't bring us closer to the core question here, which is how AI works. That is necessary for us to understand how AI can be applied in construction. We may then try and turn to AI experts for help, but they will flood us with technical terms such as generative pre-trained transformers that won't bring us any closer to understanding AI. The good news is, though, to have a conceptual understanding of AI, all we need to understand is the following three terms: artificial intelligence, machine learning, and deep learning. These three expressions are often used interchangeably as synonyms, but they are different things. And by understanding this difference is key to understanding AI itself. Let's see what each of these mean and what is the relationship between them. AI is the overall name of the category. Any machine that can do intelligent things beyond sheer automation falls into this category. Even your robot vacuum cleaner that put into any room will figure out on its own how to clean it up. Now, where does your vacuum cleaner's intelligence come from? Of course, it comes from the software that drives it. So the first thing for us to understand is that AI is software, a new type of intelligent software. Machine learning, on the other hand, is a software methodology term, a revolutionary new way to create such intelligent software. It is important to understand that machine learning is not the same as learning machines. In other words, adapting machines. The learning happens during the creation of the AI software. It is a time-consuming and very expensive process to train an AI model. Once ready, it can do surprisingly complex tasks, but that running version of the AI software doesn't learn anymore. It may collect information during its operation and interaction with the environment, but that information will only be used to train a future version of the AI model. Last but not least, deep learning, simply put, is a specific way of training AI software on unstructured data such as text or image using artificial neural networks. Now, what type of tasks is AI good at? Remember, AI learns from large data sets, but it learns not the data itself, but the logical relations embedded in the dataset it was trained on. So AI is especially good at one specific type of task, recognizing patterns in large datasets. If you look at this image, the only thing you probably see is some rocks. An AI trained on image recognition can see a lot more. Now focus your vision onto the bottom middle part of the image. If you look carefully, you will see a big cat, a mountain lion, which most probably escaped your observation at first, but not AI's. Now you may wonder, how was AI trained to recognize things like this mountain lion in images? Matter of fact is that you probably contributed to its training yourself. When you solved a CAPTCHA during a login process on the internet, you actually trained AI. As I stated, AI doesn't store actual data, just patterns in the dataset. And the best place to store connections is artificial neural networks, or ANNs. The example here shows an ANN that is trained on recognizing the portraits of American presidents. It is done through deep learning when the AI tries to guess who is in the picture, and with the help of human feedback, it gets better and better at it. The best way to understand AI may be through comparing it with traditional software such as Excel. Traditional software consists of algorithms programmed by human programmers. Midjourney, a next-gen AI software, on the other hand, was created by several months of training by showing it vast amounts of data points, 400 million images in this specific case. One last thought on AI. You may have heard the expression AI hallucination. This is when AI makes things up, things that don't exist, such as an astronaut riding a horse on the surface of the moon. It comes from the fact that AI is a statistical methodology, so it never will give you facts, just probabilistic guesses for answers. Why is it important for our discussion? Because we have to be careful when we want to apply AI to engineering domains such as construction. Even very high probability answers will not suffice in most of the cases. So we have to be careful when someone claims AI will design full buildings. Still, there are many areas where AI has very high potential in construction. So let's dive into it. AI is a disruptor, and indeed there is room for disruption in construction, that's for sure. If you look at this chart, for instance, you will see that the construction industry is the very last in digitalization, just right after fishing and hunting. We believe AI has the potential to fundamentally change that and make construction a highly digitalized sector. So let's see some examples of AI application in construction. At first, construction companies simply tried to copy and paste what already worked in other industries. If robots can build cars in factories, robots should also be able to build buildings on construction site, right? As this example shows, indeed, they technically can build brick walls, for instance. But is this really the best application of AI in construction? Probably not. Bricks were designed for humans to lay for 8 hours without exhaustion. Machines are much more powerful than humans, so let's try to use them for more than simply emulating human labor. Another early application of AI in construction was when construction companies tried to find well-fitting use cases to existing core AI technologies, such as computer vision. These days, it is common practice for construction sites to have cameras installed to catch safety breaches, such as missing protective gear on workers. This is a much more practical application of AI than industrial robots laying bricks, but still, we don't think this is the AI breakthrough we are looking for. We believe the highest potential for AI in our industry is actually not on the construction site, but in the designer's office. There are already lots of examples where AI startups try to use AI to generate optimized floor plans or even entire buildings. But these are all very promising but very early stage experiments with limited practical usability, at least for now. We at Graphisoft believe that the first AI breakthroughs will come from highly focused innovation on very specific workflow steps of the design process. We are working on several such AI initiatives at Graphisoft, many in partnerships with academia, with very promising results. Now let me give you some highlights of our AI initiatives at Graphisoft. Let me start with the very first implementation of AI in BIM, which happened a couple of years back already. ArchiCAD had the very first AI-powered stair design tool. It helps designers design code-compliant stairs by offering appropriate stair designs for any real-life spatial context. A more recent AI development that we have literally just released in the past couple of days is our AI visualizer. With the help of Stable Diffusion AI integrated into ArchiCAD 27, early design concepts based on mass models of buildings can be turned into high-quality, photorealistic conceptual visualizations in the matter of seconds. This helps architects quickly create several design concepts for their clients, simply telling the computer what the building should look like. Amazing, isn't it? To have a little outlook to the future too, one of our research projects is focused around alternative user interfaces to drive ArchiCAD. We are experimenting with the Technical University of Budapest on gesture and voice control of BIM applications. Imagine you will be able to tell your BIM software in natural language to model complex forms or structures. Simple as that. My last example may be the most boring one, but without doubt it has the biggest productivity impact, making the original promise of BIM ultimately come true. Together with the Technical University of Munich this time, we are researching how AI can potentially help turn the design of architects into full construction documentation. Wouldn't that be great? So to finish, should we be afraid of AI? Will the machines rise and kill us? Or in other words, will they take our jobs completely as designers? I don't think so. Instead, they will greatly augment our capabilities that will help us create a better built environment for the good of us all. Thank you.